Okay, so we're going to do two tests, a Kruskal-Wallis and a Mann-Whitney U test. And in the homework, I have you do Kruskal-Wallis first and then the Mann-Whitney, but I'm going to have you do that. I'm going to show you that in reverse order, actually. I'm going to do Mann-Whitney first because that's a two group test, and then we'll move up to the three group test. All right, so these are the ones that are from the homework. I am going to show you the data. We have gender, 1 and 2, and then we have pulse rate. So we're looking at pulse rate by gender. We have unequal sample sizes. We have 12 in one group and 11 in the other group. So all right, we're going to go to Analyze. We're going to go down to Nonparametric tests. We're going to slide over to Independent Samples, and it pops up this dialog. It says automatically compare distributions across groups. We're going to say Customize Analysis. We're going to click Fields. Now here it's just like a one sample t-test, independent samples t-test, where we put the dependent variable pulse rate in the test field and then the group in the groups field, right? We don't have to tell it group 1 is 1 and group 2 is 2, but I'll show you another way to do this, which I didn't show you in the PowerPoint, but I just want you to know if you ever look it up online and you see these legacy dialogues, what it looks like. So then we click Settings, and we're going to say Customize Test, and we're just going to do Mann-Whitney U, 2 samples. We're going to say Run, and it takes a second for it to run. Okay. So the first thing we see is that it says retain the null hypothesis. So the null hypothesis is that there is no difference between the two groups on pulse rate. And we see our significance level is 0.211, and we do see that we do not reject, so therefore we retain the null hypothesis. We had a total N of 23. Our U statistic, I don't know why I keep doing this, double click to activate, something's slow at my computer. There's our U statistic, the Wilcoxon W, the test statistic, standard error, etc. Standardized test statistic is the one that we will report. All right, so then what this does, this is what I call a population pyramid chart in the PowerPoint, and what we want to see is that we have similar distributions, and we do not. We have dissimilar distributions. But we don't have significance anyway, so it doesn't really matter. But that would be something that we would report. And then we come down here and we look at the continuous field information. So this histogram tells us about the pulse rates across all of the participants or the subjects. And here we have N23, minimum is 54, maximum is 98, and the mean is 74. And that's it, really. You would just report, we'd say we retain the null hypothesis or fail to reject the null hypothesis. Z equals 1.3, P is equal to 0.211. All right, so now I'm going to pull up the other data set. All right, so now I have pulled up the Kruskal-Wallis data set from the PowerPoint, and we have code 9 levels plus smoking level. So let's go look at those value labels. So this is a continuous score, so there's no label. Here we have smoker, contact smoke, and no contact smoke. So these non-contact smoke people are the people who have absolutely no exposure to cigarette smoke. And then the contact smoke people are people who live probably in the house with the smoker, and then number 1 is the full-on smoker. So we do the same thing. We're going to go to Analyze, Nonparametric Tests. Again, independent samples. We're going to customize across. We're going to look at the code 9 levels across smoke levels. We're going to hit Settings. We're going to customize test. We're going to do this Kruskal-Wallis one way and leave this all pairwise. Let me reset it and do it again. All right, so we're going to go to Analyze, Nonparametric Tests, slide over to Independent Samples. I'm going to customize. I'm going to click Fields. I'm going to bring categorical dependent variable to my test field and my grouping variable to groups. I'm going to click Settings. I'm going to click Customize Test. And last time we did Mann Whitney, now we're going to do Kruskal Wallis. We will leave all pairwise. We could do the pairwise or the stepwise step down, but we just want all pairwise, so just leave it. Then we hit Run. Let me see where my output went. Okay, and so we are looking at so it says the distribution of code 9 is the same across categories. That's the null. We're going to reject the null because it is not. It gives us a bunch of default output, and that's fine. Our n was 120. Our test statistic is 62. Our degrees of freedom is 2, and our p-value is 0.001. So we can see that the smokers have much higher levels of code 9 and a longer range. Here we have a few outliers, but for the most part, theirs is 0 for the contact, and then for no contact smoke, it's practically 0 with a few people who have some levels in their blood. Okay, so then the way we evaluate this is just like a least significant difference. The people between no contact smoke and contact smoke were significantly different. The people between no contact smoke and smoker were significantly different. And then the contact smoke and smoker were significantly different. And it gives you this kind of weird little visual. And I've looked around on the internet. I haven't seen so much about how to interpret this, but if you look, we can intuit what they mean. So between smoker and no contact smoke, that is the biggest difference, and this is the thinnest line. All right, so that no contact smoke and smoker, their test statistic was almost 8, and so that's the strongest level of significance there. Then we have contact smoke and smoker, which is this little bottom one, which is a little bit higher. So this is a slightly thicker blue line, and then the thickest blue line is the one with the smallest level of difference. But they're all highly significantly different. So, you know, this isn't, it's groovy looking, but it's not something that we really need. This is what we need. And then here's the distribution, the histogram of people in the data set. So the greater proportion of people had 0. Between 0 and probably 50 level of code 9 is about 80 or 75, 78 people. And so that's the continuous level, and then this is obviously the grouping variable, and we have 120, so we have the same across 40, 40, and 40. Okay. Now, the one thing I did say I was going to do is show you how to do this in legacy dialogue. So if you go to Analyze, and you come down to Nonparametric Tests, and you go across to Legacy Dialogues, then you get this other set. You've got chi-square, binomial, runs, one sample, KS test, that's a Kolmogorov-Smirnov test, 2 independent samples, K independent samples, that's this one, right? Because K stands for any number more than 2, right? So let's do that one. So it looks like the ANOVA test. It's highlighted Kruskal Wallis for us. We're going to bring the code 9 over. We're going to bring the smoke level over. We have to define it. So the minimum range for the grouping value is 1, and the maximum range is 3. We're going to say continue. We're going to say exact, asymptotic, that's fine, it's just default. We're going to ask for descriptives, and then we're just going to say okay. Alright, so same thing. We don't get all the bells and whistles like we do up here. We don't get the box plot, the groovy triangle graph, but we do get the same information. Alright, same test statistic. This is a chi-square. We report this as a chi-square. And then we get the mean ranks for each of these. And then you would do the same thing if you wanted to do, I'm not going to do it with this data set. Where is it? Nonparametric, come across, independent samples. Oh, sorry. Legacy dialogues. Legacy dialogues. And if I were to do independent samples, it looks just like the independent samples t-test, right? You'd have to group it, do the code 9, do the grouping variable, You get those little questions. Now, there is 3 groups in this data set, but this is only to test 2, so I'm not going to run that one. But I just wanted you to see that. If you're looking up on the internet and somebody shows you a legacy dialog version, it's the same thing. You just don't get as much output. Okay.